Hi everyone, we're going to talk about reaction rates in this video and how we can speed up reaction rates. So we're going to review really quick about our energy diagrams. So if you watch the previous video, okay, so if we have, I'm just going to draw just a real simple reaction. We've got this is our energy of activation. That's supposed to be an arrow there. And then if we had a reaction that looked like this, so it has a much higher energy of activation. Okay, this is a faster reaction because it has a lower energy of activation. Remember, we have reactants, products, and then energy. Okay, so I know this is real not very pretty looking here, but all right, so if we have a lower energy of activation, this is faster. The energy of activation is much higher. It takes a lot more energy to break those reactant bonds, and so this is slower. Okay, so how can we speed up a reaction rate? One thing you can do is increase the concentration of your reactants, or increase the amount of reactants that you have. So we also talked about in the previous video that we have to have collisions of our molecules in the right orientation and with enough energy. So if you increase that concentration and you have more and more reactants, so if you're in the lab and you put a higher concentration of your reactant molecules, then this can increase the number of collisions, right? If you have more molecules, then the more collisions can occur. The more collisions that occur, then the more bonds that can break and of course form new bonds. Okay, so that's just kind of the more you have, the more likely that the reactants will collide in the proper orientation. All right, so then you can also increase temperature. So think about it, if you heat something, just like if you're heating just water or something, salt water, and you watch those molecules, okay, and those water molecules start heating up and they start moving at a faster rate, and then it boils, okay, and so you're increasing the kinetic energy of the molecules, or giving them more energy, and so this also can increase the reaction rate. So if you increase the temperature, you give those molecules more energy to be able to get over that energy of activation barrier. You can also use what's called catalysts, and these are substances that speed up the rate of reactions, and they're also recovered. So that means after the reaction is done, they're unchanged and they do not appear in the product. Okay, for example, this is actually an organic reaction, and palladium is a metal that's used as a catalyst, and so it speeds up the reaction, but it's not involved at all, so you don't see it. There's no palladium over here in the products. Okay, so catalysts will accelerate the reaction by lowering the energy of activation, okay, without affecting the delta H. So let's see what this looks like. Okay, if we had a reaction, okay, same reaction, okay, this blue, this one is uncatalyzed, so we ran this reaction with no catalyst. Okay, it has a higher energy of activation, so it's pointed to right here. Okay, so it's going to be slower. Okay, so the uncatalyzed reaction has a higher, it's right here, energy of activation. Okay, remember that energy of activation is the difference in the reactants to our transition state. That's the transition state there. Okay, it's higher, so it's slower. It takes more energy to get the reactants there. All right, and then if you use a catalyst, okay, see how the energy of activation is lowered. Therefore, the lower the energy of activation, the faster the reaction. So the catalyzed reaction is faster. And there's lots of examples of catalysts in the chemistry lab. Palladium is very common that we just saw. You can have iron catalysts, a lot of metals. Some of these can be expensive, some cheaper, just depending on what they do and how they're utilized in the lab. But I do want you to see that your delta H is not labeled here. Okay, delta H, just to test you real quick. So is this reaction, is it endothermic or is it exothermic? Okay, so here's your reactants. Delta H is the difference between reactants, energy and reactants, and products. Okay, here, products are higher in energy than the reactants. Okay, so this is a positive delta H, meaning it is endothermic. The human body has biological catalysts that we are very thankful that we have. Most of these are enzymes, usually proteins, and they are biological catalysts. They're in three-dimensional shape, and they have an active site that binds reactants, and they undergo a very specific reaction with an enhanced rate in our bodies. Okay, and so this is going on all the time. The enzyme lactase, it converts carbohydrates, lactose, into two sugars, glucose and galactose. So people that are lactose intolerant, they lack the adequate amounts of lactase. And so they suffer from intestinal issues because they can't digest lactose, okay, which is obviously from milk and dairy products. Okay, and so this is how it works. So you have this enzyme in your body that has a very specific active site. And so lactose will bind to it, and then it, in a catalyzed reaction, it breaks bonds, forms new ones, and you break down the lactose into galactose and glucose. So it breaks it down. That's what that enzyme does. And then it leaves your enzyme left there unchanged. That's what a catalyst does. Remember, it doesn't form a product. It basically catalyzes it. And then once you get your products, it's left unchanged and can be used again and again and again. But someone who lacks these enzymes in their body, obviously they can't break down the lactose properly, and that's why they have intestinal issues from that. All right, I hope this helps with reaction rates, and I will see you soon.